In this class, I will talk about semiconductor. What are semiconductors? Semiconductors are materials those behave as insulator as well as conductor. How is it possible? Let's see the energy band diagram. This is valence band. It is the highest field of band, and this band is formed by valence electrons. So the band is called valence band. In valence band, the electrons are not free. They are bound in covalent bond. So the electrons are still in the valence band. They do not conduct electricity. This is the conduction band, and it is empty band just above the valence band. And in the conduction band, electrons are moving freely and they are involved for the conduction of electricity. This is the forbidden zone. There is no any allowed energy state, so no electrons are there. This is here EV is the energy of the top of the valence band, and EC represents the energy of the bottom of the conduction band. And the difference EC minus EV equal to EV is the band gap energy. When EV greater than 3 electron volt, the materials are classified into insulator. But when EV less than 3 electron volt, the materials are classified into semiconductor. But for most common semiconductors, silicon has band gap EV equal to 1.12 electron volt, and for germanium EV equal to 0.72 electron volt. Thus, at least band gap amount of energy must be given to the semiconductor substance to behave the semiconductor as a conductor. So at T is equal to 0, no electrons are in the conduction band. All the electrons remain in the valence band, and the semiconductor behave as insulator. And when T is equal to high, at least room temperature, then the sufficient number of electrons go to the conduction band from valence band, and they are involved for the conduction of electricity. So the semiconductors sometimes behave as insulator when T is equal to 0 Kelvin, and when T equal to high, the semiconductor behave as conductor. But at high temperature, but with increasing of the temperature, the number of electrons in the conduction band it increases. So the conductivity of the semiconductor increases with temperature, just opposite to the metal. So the temperature coefficient of a semiconductor is negative. But for the application, the conductivity of a semiconductor is not sufficient. So to enhance the conductivity of a semiconductor, some impurity atoms are added with the semiconductors, and a semiconductor with some impurity is called extrinsic semiconductors. All the semiconductors in pure conditions are called intrinsic semiconductors. Intrinsic semiconductor such as germanium, silicon, arsenic, all are pure semiconductor and they are called intrinsic semiconductor. But with impurity, semiconductors are called extrinsic semiconductors, and extrinsic semiconductors are two types: N type and P type. We know all the semiconductors are available in crystalline form, means in crystalline structure all the atoms are regularly arranged. For n-type semiconductors, pentavalency impurity atoms are added with silicon or germanium environment. Let here the tetravalent valency materials is silicon, and here pentavalency impurity atoms arsenic are doped with the semiconductor, and so some of the silicon atoms are replaced by the impurity atom arsenic. Say here arsenic atom replaced one silicon, and silicon form 4 covalent bond with nearest neighbor silicon atom by sharing electrons with opposite spin. But since the arsenic has 5 electrons in its outer orbit, so 5th electron become free, and this is almost free. That means the impurity atom donate the 5th electron, and each impurity atom donate his 5th electron. So huge number of electrons are developed due to the addition of impurity in a pure semiconductor, and also due to the breakage of covalent bond in the valence band, number of electrons from the valence band go to the conduction band, and in turn produce hole in the vacant state in the valence band. But here the number of electrons is are greater than the number of hole in the valence band, and since the electron carry negative charge, so this is called n-type semiconductor. And since here electrons number of electrons are greater, so here the majority carriers are electrons, and minority carriers are hole. In the same way, if trivalency impurity atom are added with silicon environment, then number of silicon atoms are replaced by impurity atom. Say here aluminum are doped with semiconductor, and this is the aluminum impurity replaced one arsenic atom, and aluminum is also will try to form 4 covalent bond by sharing electron with opposite spin. But since aluminum have 3 electron in the outer orbit, so one vacant state is produced, and nearest electron in the covalent bond, they will try to fill up the vacant state, and the electron come to the vacant state, then in turn hole is developed there, as if hole is moved in that direction opposite to the movement of the electron. And since in the valence band electrons are bound in a covalent bond, so higher energy is required to move the hole from one position to another position, so the effective mass of the hole is greater. Thus we always prefer electron as a majority carriers for high speed device. Thank you.